In this problem, we return to an earlier differential equation where we know the solution already. We've seen this a couple of times. We know that the solution is some constant e to the kt. What we'd like to do is discover that without requiring knowledge about derivatives, but simply through the process of separating the variables. And it turns out it's straightforward. What we're going to do is separate and integrate. And when we do that, we're going to naturally progress and discover the solution ourselves. So we'll bring the dx up. We'll bring actually the k on the right-hand side. It's up to you. The k could be on either side. Let's leave it on the right, though. But we will bring the y down to the left so that our y's are uniquely identified on the left-hand side and the x's are on the right. And then we integrate both sides. On the left, we get a ln, and on the right, we have a kx plus a constant. Having completed the integration, our next step is to exponentiate because we want to get y equals. And that simply means putting an e underneath the entire left-hand side and using e as a base for the entire right-hand side. E and ln are inverses, and as long as we're careful about our rules, this is e to the power of a plus b. That's the same thing as multiplication down to the exponents here, multiplication of the bases rather. And what we'd like to do is get rid of the absolute values. And we're going to use the same trick we've seen before. We're going to create a new variable, call it a, which is equal to e to the c, but as we take away the absolute values, we might need a negative or a positive. We'll also lump that into e to the c and give that new combination of terms the name a. So we get rid of the absolute values, e to the kx stays as it is, times a, and we just tidy that up a little bit here. And that's it. Notice the constant that was a plus c of integration ends up being a multiplication factor when we're done here, and that's again very common. In the previous solution, the independent variable is t. We would end up with e to the kt. If our independent variable is x, we end up with e to the kx. But what this gives us in the end, of course, is a solution to the differential equation worked out from first principles using separation of variables.